All right, so in assignment number 3, we're going to be finding the components of vectors. So let's just take a look at this problem. We have the Titanic going down right here, and suppose that we had a Coast Guard ship at the same time that was nearby. The Titanic could have sent out an SOS signal to the Coast Guard so that the Coast Guard could have come and saved them. Of course, the Coast Guard would need to know which direction to go. They would need a direction and a magnitude. And so that's what a direction, or that's what a vector has. It has both a direction, which way do we need to go, and how far away is it. And so those are two parts of a vector that we're going to need to talk about. But let's say we have the original vector that has a direction and a magnitude. There's also two components for a vector, and that's the horizontal component, which is how far over it goes, like on the x-axis, and then how far up it goes on the y-axis, called the vertical component. And so let's go back to our original question with the Titanic and the Coast Guard. Here's our vector, and this vector has a magnitude, which is the distance of 5.7 miles, and we would say that it is 26 degrees north of east. And so this direction here is east, and so we want to go north of east, so at a degrees of 26 degrees. And so that's our direction and our magnitude. What we want to find are the two components, the horizontal component, which is how far over does it go, and then also the vertical component, which is how far up does it go. And so this is our angle that we're talking about. This is the opposite side here. We could also call that y. And this is our adjacent side here, and we can call that x. And so let's do the x part first. Let's find our horizontal component. That's the adjacent side, and we know this side, which is the hypotenuse. Adjacent over the hypotenuse is the cosine. So I'm going to take the cosine of 26 degrees, and that's going to give me the adjacent side, which is x, over the hypotenuse, which is 5.7. And so then we can actually use this to figure out what x is. Now I'm going to multiply both sides here by 5.7. So on the right, I will just have x. And on the left, I will have 5.7 times the cosine of 26 degrees. And that gives us an x value of 5.123. Now, if you're using your graphing calculators are automatically in radian measure. So you want to go ahead and put them in degree measure, which means you have to press mode on your calculator, go down to the third thing where it says radian, and move it over to degrees. One way to measure degrees, which we haven't talked about yet, but we will tomorrow, is that you can measure degrees in radian measure, and you want to make sure that you are in degree mode. So this is the vertical component. We're going over 5.123 miles. But then we want to figure out the vertical component, the y value of this. Well, the y is the opposite side, and so the opposite over the hypotenuse is the sine function. So I'm going to take the sine of 26 degrees equals the opposite side, which we're going to call y, over the hypotenuse, which is 5.7. And if I multiply both sides by 5.7, I'll have that y is equal to 5.7 times the sine of 26 degrees. And that's like 2.498, which I'm going to round to 2.5 miles. So it's 2.5 miles is the vertical component. So there's a pattern here. I want you to look at this right here. How do we find the vertical component? We took the magnitude, which is the 5.7, times the sine of the angle. To find the horizontal component, that's right here, we took the magnitude times the cosine of the angle. So let's use that same process to find these components. So we can try to find all three of these, A, B, and C. We actually can do C first. That's just going down a total of 46.8 units. And so that's just going to be at the point 0 and 46.8, which means the vertical component, which is x, is 0, and the horizontal component, actually we would make that negative because we're in the going down 46.8 units. So that one we don't really need to use sine or cosine at all, but let's take a look at A here. So we want to find the horizontal component and the vertical component. The horizontal component, which is x, can be found by taking the cosine of our angle measure, which is 28 degrees, is going to equal the adjacent side, which is x, over the magnitude, which is 66. We can simplify that. Maybe we don't need that step. Maybe we could have just said that x equals the magnitude, which is 66, times the cosine of 28 degrees. And that gives us an x value of 58.27. 58.27. Then if we want to find the y coordinate, that's the vertical component, that's the opposite side. So I could say that the sine of our angle, which is 28 degrees equals the opposite side, which is y, over 66. But if I multiply both sides by 66, maybe I don't need that step. Maybe I can just remember that y equals the magnitude, which is 66, times the sine of the angle, which is 28 degrees. And if I take 66 times the sine of 28 degrees, I will have 30.98. 30.98. So if I want to find the coordinates, I'm going to have the x value, which is 58.2, let's say, and the y coordinate, which is going to be, I'm going to round it to 31. And that's where this point is at. If I want to do the same thing for the value for b, I just have to watch now what the signs are. So the horizontal component, this distance here, I'm going to skip the first step that I had here and just say that x is going to equal the magnitude, which is 40, times the cosine of my angle, which is 56 degrees. And so if I take 40 times the cosine of 56 degrees, that gives me 22.37 if I round up. But I'm going to say that it is negative 22.37 simply because of I want to give it the direction, which is to the left. And so it has to be a negative value because I want my x to be a negative number. So the x value is negative 22.37. And then to find the vertical component, I'm going to skip the first step, which I had here, and just go straight to this step. I want to say that to find y, I'm going to take the magnitude, which is 40, and multiply it times the sine of 56 degrees. And so if I take 40 times the sine of 56 degrees, that gives me 33. Y is 33.16. And so I would have my x and y coordinates, which is going to be negative 22.37 for x, and the y value would be 33.16. And so those are how I can find the terminal points of all three of these vectors. Let's move this and talk about the opposite direction, or at least shortcuts to the components. And so I have the horizontal component is always the magnitude, which is the a value, times the cosine of the angle measure. Then the vertical component, which is the y value, is always the magnitude times the sine of the angle measure. And so these are two formulas to remember on how we can find what the y value is and how we can find what the x value is. X is always associated with the cosine, and the y is always associated with the sine. So let's take a look at this and go in the other direction. Here, the first one, for part A, we have a vector that is 10 kilometers north and 5 kilometers west. So if this is my origin here, then that would put me at a point that I'm going to say is the point, -5 and up 10. So that would be my horizontal and my vertical components, but I want to find the direction and the magnitude. So let me first find the magnitude of this vector. I can do that using the Pythagorean theorem. We know that 5 squared plus 10 squared equals the magnitude of the vector. I'm just going to use m squared for the magnitude. Well, that's 25 plus 100 equals m squared. That's 125 equals m squared. If I take the square root of both sides, I'm going to get that m, the magnitude, is 11.18. Now that's if I round it, 11.18. I could find the exact measure by taking the square root of 125 and simplifying it. That would give me 25 times 5, which would be 5 radical 5, if I wanted to leave it in simplest radical form. But for right now, we're just going to say the magnitude is 11.28. But then I want an angle measure. So if this is my coordinate grid here, I want to know what is that angle measure. So I'm going to find that angle measure because I know that the opposite side is 10 and the adjacent side is 5. So that means that the tangent of my angle measure, I'm going to call it theta. The tangent of theta is equal to 10 over 5, which is 2. And so I'm just going to do the inverse tangent. And so if I go the inverse tangent of 2, that gives me an angle measure of 63.43 degrees. So that means my angle measure is 63.43 degrees. And I would describe that as being north of west. Okay, because this direction would be west. So I want to go how many degrees north of west. And so that's how I find the magnitude and the direction for the first arrow. I would pause the video right now, try to do number B on your own and see if you come up with the same thing that I come up with. First of all, to find the, hopefully you did this, the magnitude is going to be 50, because if you do 30 squared plus 40 squared, that equals r squared. Use the Pythagorean theorem, you're going to end up that is 50. You can also remember it because it's a Pythagorean triple. 3, 4, 5 triangle is the same thing as a 30, 40, 50 triangle. So the magnitude is 50. But then I want to figure out what this angle measure is. And so I know that this side over here is 40 and the side down here is 30. So I can say I want the tangent of my angle measure. I'm missing some of this. The tangent of my angle measure, I'm going to call it theta, is equal to 40 over 30, which reduces to 4/3. And so then if I go the inverse tangent of 4/3, that gives me an angle measure of 53.13 degrees. So that means theta is 53.13 degrees, and I would say that's north of east. So that's what you have here for assignment number 3. We are looking at vectors and describing vectors, sometimes by giving the components, and we have to find the direction, the magnitude, and then sometimes we're given the direction, the magnitude, and we have to find both the vertical and the horizontal components. Big idea here is that the horizontal component is always the magnitude times the cosine of theta, and the vertical component is always the magnitude times the sine of theta. We'll go through this assignment that you have for tonight, tomorrow in class, and go over questions that you have. We will see you then.